Hi, my name is Mattias Ljungström, and I'm from Sweden, but I'm based in Berlin. In 2009, I founded the studio Space to Play together with my partners, and we have released a few projects. The one that we're most known for, I think, is our game Spirits, which was an iOS game, which we later brought to PC, Mac, and Linux, and Android. And it's a Lemmings-esque puzzle game where you bring a tribe of spirits from point A to B. We've done a couple of other side projects. One worth mentioning is an iPad application for the Quizware comic, touch sensitive. And it's only available on the iPad, custom made for the iPad. But today, I'm going to talk about our game, Future Unfolding, which is the last game that we did, came out in 2017. Future Unfolding, it's an adventure game with a strong focus on exploration. Progress is made through the game by finding new paths and by solving puzzles. Puzzles are usually some kind of objects that stands out in the environment. They don't have really a clear indicators. Instead, it's sort of up to the player to recognize these elements as something that stands out. And the game takes place in a sort of colorful forest environment filled with friendly and hostile animals. And I want to explain how we use procedural generation in combination with our custom level editor to generate the aesthetic feel that we wanted to have with, at the same time, to have large variation, but also having a control of the game design parameters to enable sort of a puzzle progression through the game. So basically what we try to do is to combine hands-on level design in combination with procedural content. And to just give you a little bit more background information, I'm going to show you a short video of the game. Okay, I'm not sure if my computer actually shared the sound there or not, but yeah, let's hope it did. So sure, this is a talk about procedural content, but I want to talk about the way we thought about procedural content versus design. And in particular, I want to talk about how we try to use procedural system to generate what we call meaningful content. And I think you all know that procedural content is not some kind of magic wand that you can just like wave over your game and it creates a lot of free content. There are a lot of many reasons why you should use procedural content. And for us, the main reason was that we wanted to have every player should have sort of a different experience and see the game in a different order. And that doesn't mean that each player has like a unique experience. Because you mostly see the same content in the game, but you see in a different order, and also makes it hard to just go online and look up the solution, for instance. So this was our motivation, and I think for everyone has like a different motivation. So everything I'm saying in this talk is just based around like what we thought was right for our project. So it should not be seen as like ground truth or anything. But for us, it was really important that procedural content was also like meaningful content. And it's very easy to make a game where you have sort of like 10 billion different locations in it. But for this to really be meaningful, there has to be some difference between those places. Otherwise, the player is just going to feel that they're just in the same location, but everything is red instead of green. And if you only have this sort of like 20 maybe meaningful variation, maybe you could have might as well created those by hand, and it would have been even more powerful than your procedurally generated 20 or like hundreds of places. And so this was something we thought about quite a lot. And for our game, it meant that we created a lot of different procedural subsystems that sort of hooked into the game design at various places to solve very specific problems. And technically, we can sort of divide the systems into the macro systems, the middle systems, and the micro systems. There are, of course, like more than 3 systems, but I think this division makes a lot of sense. So what do I mean by this exactly? On a macro level, the world generator creates unique worlds based on rules and condition. And what you see here is the view from our level editor tool. And what you see is one world in the game. And the world is a collection of areas or scene that we organize on a grid. And a grid because it was the easiest way to do it, and it kind of worked. So yeah. On the micro level, we have system that handles placement of the individual elements for decorations. It's like, how are the ground brushes generated? How are the flowers, the bushes, and the trees placed? What rules do we have for their placement, basically? And in the middle level, that's the layout of a single area, a single scene that we call them. And these are crafted in our custom level editor by placing abstract nodes and then attaching properties to them. And the nodes are connected with path that creates like paths and open areas in the scenes. And node can have random offset, it can have random alternatives. So for a given location, we can have create really like a tree sort of graph of different variations of things that can be placed into the level. But these are sort of, these are handcrafted, but they then generate different instances. So this particular level, this is a screenshot from the level editor, will generate an area that looks like this in the game. Or it can look like this with a different seed, or it can look like this. And the common factor here is that it's a quiet, open area with 3 exits. It's flat. It's like there are no height differences. And this is basically one of our starting areas in the game. And so this is a short overview. We use something called Voronoi cells to create sort of organic look in the game. Voronoi cells are used basically in all procedural games, so I'm sure you've at least touched on them or heard of them before. We also use them for path and pathfinding. Paths are created in the world through the Voronoi cells, which makes an organic look. And the real-time pathfinding for animals and enemies are also done through the Voronoi cells, which also creates sort of automatically organic pathing, because you're never going to have anything moving on a grid towards you. It's always going to run in a sort of wiggly way towards you. So if you want an organic look, Voronoi cells are great. This is the same area again, just without the debug view. You can see how the tree placement creates kind of organic look. On the other hand, if you just use the Voronoi cells really with sharp edges, which you can see on the hill in the bottom left corner, it actually kind of creates hard edges. So this is maybe not really organic, but yeah, depends a little bit how you use it. So I just want to mention, I think a lot of you have heard about Voronois before, but Voronoi diagram is space division where each cell is defined as the area that is closest to a certain point. So to generate it, you just generate a lot of random points, and then you create a Voronoi diagram for these points. But then it's very important to use something called Lloyd's relaxation to iterate over these points, because naive Voronoi diagram usually has the cells being in very different sizes. And to have a sort of smooth layout, it's very important to have this relaxation process where you iterate over it a few times. It's actually really key to having a good look. So here's another example of a path through the Voronoi cells. You can see how the brown path is going through each of these cells. The same again with our debug view. Color tilting is another really important tool to create variations. But again, it's something that you have to be careful that it actually doesn't create that much variation, but it's still important in the sense that you can sort of use it to group areas together and then change the color as the player moves through the world. Here is the same location as you had in the previous slide with a different color and also upside down and a different seed. So I'll just go back and forth between these two a few times to give you a chance to see them. And what we realized when we had started building the game was that you actually need very small variations for an area to feel like a completely different area. Like, not a lot of people would say, oh, look at these two screenshots and be like, oh yeah, those are the same area. And so when we started out, we thought we needed a lot more randomness than you actually do to create sort of this mental distance between two spaces. But then again, we also come back to the uniqueness problem. There isn't a lot of things that are unique between these two locations. So we can't just create like billions of color variations and call them all unique. There's a limit here. And in our particular case, the limit had to do with how much art we could create manually. Because as you see on the screenshot, we have a rock, we have a deer, we have like rabbits here, we have these bushes. They're like random variations on them, but they still have distinct look. We didn't have like a spore-like system where we could create any type of stones or any type of animals. These were still hand animated and so on, just with variations to them. So for us, the limit on number of unique location came down to how many unique animals can we make, how many unique puzzle elements can we actually create, and so on. And had very little to do with actual procedural generation. The procedural generation was just a way to have this variation on top and then making things being placed randomly and differently for each player. So I want to talk a little bit more about macro level world generation in detail. So let's jump into it. This is from our level editor again. A lot of different worlds being generated. It's just basically me cycling through and recording this. I'll explain more in detail what's going on. So the world layout in Fusion Folding, it's generated up front, but it's not static. And the complete game consists of 9 worlds. Each world is generated as you enter it. So we don't generate the whole game up front. Instead, we generate the first world, and then when you finish the first world, you go into the next world. We will only generate the second world at that point, because we use the information about what puzzles you solved in the first world to place stuff in the second world. And this I'll come back to this later. But the world is built up in world areas or world scenes. We did this because it was the easiest, and there's definitely a lot of other ways to do it. And each world area can have 1 to 4 exits in the up, down, left, right directions. And each area can be placed in 8 different orientations. So it can be rotated 4 times, and then you can also mirror it and rotate it 4 times. So you have 4 plus 4 states, or 4 orientations for a certain area. The game starts by placing the start area randomly in the grid. In this case, it's placed in the center. And we then place what we call a major area. This is basically the goal area of the world, and usually contains a hard puzzle and the endpoint. And this is all placed as far away as possible from the start point. In this case, you can see it's only like 2 steps away. Then we place something we call minor puzzles. And these usually include puzzles that introduces stuff to you as a player that you need to know to solve the major puzzle later. So we want to enforce that you work through at least one of these minor puzzles before you reach the major puzzle. Then the game flood fills the world with what we call these normal areas. There's the red and green room in this image. And we can set parameters at this stage, how much branching should happen. So if it should create as few branches as possible, this is between 0 and 1. Or if it should branch a lot, meaning like 3 or 4 branches. And there are also shakes to enforce that the world has or doesn't have cycles in it. More about this later. But why is it important to decide how much branching you want to have? So it actually influences the game flow quite a lot. And if you have a lot of 2-way areas, you get a very linear flow through the world. You almost never have to make a choice where you go. You just like keep going straight. A very, very linear progression through the world. If you have a lot of 3- or 4-way locations, you usually automatically get a lot of small loops in the layout, where the player can spin around for a while before they figure out where they actually have to go in the game. So in this case, you have like 3 different loops in the layout where the player can spin around. And then after the world has been generated, we validate the layout using a few optional conditions. So we don't use these for all, like we only use them. So we can require a world to have loops. We can require a world to not have loops. We can require that all path goes through the minor area. This we usually do. We can require that you also go through a normal area between. So it means that we could throw away worlds where you just have like the start and then minor and then the major and so on. And the way this works is basically after the world has been generated, it goes through all of these validation tests, which includes pathfinding. If it fails any of the tests, we just discard it and generate a new layout. And for some of our setup, it means that the computer actually has to try like hundreds of times before it finds a valid layout. But this is actually fast, especially since we're just doing this on sort of like a 5 times 4 or even sometimes 4 times 3 grid. Using brute force is totally fine. We don't have to figure out a way to generate the good solution directly. We can just set up all these validations instead, and then ask the computer to keep trying until it finds something that it's actually good. So this sort of covers how the world is set, but we actually also do some tweaks to the world layout while you're playing the game. And let me talk about this. So, and this is actually funny because it's something that we figured out quite late in the process that we needed to have, is this situation, especially where you have a lot of branching and you can walk around in the world. It means that you could have a situation where you sort of walk around the world and then enter an area from backwards, basically. And a lot of the puzzles that we design, they don't really work. They only work if you enter from the correct direction. And to solve this, trying to make sure that the player, at least most of the time, sees the puzzle in the right direction, we are actually flipping levels around based on which direction you enter them to, so that you will always play it through in the intended direction. There are, of course, situations. For instance, you could enter an area, then immediately go out, then walk around the world and enter it from the other side. Then we're not going to flip it because you've already been in there, you've seen it, so it doesn't make sense for us to flip it at this case. But if we haven't instantiated an area, we will flip it. And this actually turned out to be really important. So it's something to keep in mind. And areas, another important thing that we found through the process was that it was quite important that we could upgrade areas. So a certain area, a certain scene maybe has like a simple version, and then a slightly harder version, that's version B, and then like a hard version, that's version C. And if the player has played through the previous versions, you will be upgraded to the more hard version. And this also can happen dynamically if, for instance, for some reason the same area is placed twice in the same world. The second one will be, if you solve the first one, the second one will be upgraded to a more hard alternative. But this is also sort of a complex system where we can also say, like, if you've seen any other area where we also solve the puzzles, so we have flags that we can see if you solved a certain puzzle or not. And then we can say, like, if you have solved this and this puzzle, then show this room or this scene. And if not, then take this like more generic puzzle. So why do we do this? This is actually really, really important in a puzzle game, that you have a sort of a sense of progression. And especially in our game, because the layout is very random. You could start in any area of the game at any time. And if we hadn't had this system, we would have had to make the game equally hard all over. We couldn't have made the game harder as you keep playing, like, because we don't know if you start in world 1 or in world 5. So we can't make world 5 harder than world 1, because if you start in 5, you're gonna like not keep playing. So this was really important for us, and I think it worked out well in the game. So let's come back to the micro placements, and I'm going to talk a little bit about this. And after the slideshow, I'm going to also show our level editor. Hopefully that will work. But let's first talk about it, because I think it's going to make it easier to understand what's going on later. So this is the game without any objects. This is our ground. And the ground is built up with brush particles. And these are placed with a noise system in combination with a color palette that's been like manually tweaked. And what's interesting here is that we decided to change the color palette slowly over the ground, so that each Voronoi cell actually has like a fixed palette. And as you move through the world, the palette is like slowly changing. And this again ties back to this, to the whole color variation, and creates a sort of a sense of progress, where if you walk very far away in the same scene, the ground color is actually slightly different. So let's get to the object placement. The object placement is a two-part problem. First, you have to select which objects to place, and secondly, you have to select where to place them. So let's see how we do that. So which objects to place is done with something that we call object pool system. And this system is based on rules which combines both randomness and the need for restriction. And each of these object pools defines a group of objects that can be placed next to each other. And we also have groups that include almost all of the objects when we want to have like a very random area. But we have these restrictions also where we say like we're not going to place more than 2 or 3, 4 objects together. And we also have restrictions where we say we don't want a flower to be placed next to like a huge tree. So we don't want to have a situation where it's like a tiny flower, huge tree, tiny flower. Instead, we want to have objects that sort of fit well organically together. And in our level editor, we can place areas, and in this case, we place like a high diversity area with no large object. It doesn't really matter the name, but that's the density is set to sparse, and it means it's sparse. And this is how that would look in the game. So you can see we don't really cover the ground. It's actually very sparse. There's just a few areas. It's not very populated. But that same object pool could also generate an area that looks like this, which is also a sparse sparse area. And the actual placement of the objects are done with different rules for the large objects and a second set of rules for the small objects. So the large objects are the bushes, the trees, and the rocks, and the small objects are the flowers and the small stones. So larger objects are placed more according to designed artistic rules. And iterating on these rules was quite a long process. And it was really like a combined effort between the artist and the code. And what you see here is actually a mock-up that Marek did, our art director did, to illustrate the different visual properties that he wanted to have in the game. And you can see that like bushes are placed in clusters, and always in combination with like 1 to 3 different objects, and smaller objects are placed more organically or more like noise, roughly simulating the way like flowers would spread over a field. And we also call these noise objects in the game. Here's just another diagram scratch where we try to break down the rules for how objects can be placed organically, based on like starting from different Voronoi cells. Here's an example of bushes placed with a normal density in the game. So we use the placement is also using the Voronoi grid as a guide for placing the object. Each cell is assigned an object pool and a density, and the algorithm starts placing the objects from the center, but sometimes you can also leave out the center. And we never place more than 3 different object types into the same cell. And this really helps with the organic look. Here's an example of flowers being placed as noise. here's the zoom in of the same thing, where flowers place the noise, but also with debug visuals. And small note for performance, you can see on the circles that none of these flowers are actually overlapping each other. And this means that we can have as many flowers as possible. And this actually becomes quite important for performance later, because we want to have as many objects as possible in the game, but we don't want to have like a lot of flowers being placed under a tree, and then the game engine has to draw them because it doesn't really know that they're under the tree, and we're losing frame rate because of that. So this is something we worked really hard on to try to maximize the amount of visuals that you get for everything that we place. And all the objects in Future Unfolding are also dynamic. There are no static objects, and even the ground can be animated. So this was also sort of a challenge, of course. And now we come to the live presentation, and I think anything can happen now. So I'm gonna try to switch out of this. Yes, that worked. Hope you can still see my desktop. Hello. Okay. I'm gonna I need to move some stuff around here, sorry. Okay, I hope you can see this. Okay. If you can't see this, let me know. Okay. So see, I have not been reading the chat because the chat was at a different screen and I didn't see that. So yeah, we're using I'm GUI. It's really neat. The game is 2D art, but we're actually drawing it in 3D. So it creates sort of a parallax effect. And then we're also doing like sort of a funny thing with the shadows, where the shadows are actually generated from 3D models. And I did a GDC talk about that in 2015 that you could look up. Okay, so let's do something here in the editor. As I mentioned before, the editor is working with nodes, and I've just placed a node here. I can move them around. There's a grid in the background, but that's just like for visual guidance. It doesn't have anything to do with the world. It's just like measurement. So I'm gonna create an area here. I'm gonna create another node and a spawn point. So this blue square here is the spawn point, and that's should be enough to hopefully get that. Okay, I think my computer is a bit slow here from all the streaming. I'm gonna close Keynote. Okay, so that's not that interesting because, okay, there we go. So here's that area that we actually created. It doesn't actually do anything because we haven't placed any other objects. So let's go and do that. And here I'm going to do some magic commands, and you're just going to have to believe me in that I'm now placing trees all over this with a global object, which is different from the object tools that I talked about earlier. And but we now have trees everywhere, except for our little area that we cut out. And everything is really slow. But there we go. Yeah. So now we have a nice open area here. And if I turn on the debugging, you can see that this area is cleared not by this perfect circle, but by clearing all the cells, all the Voronoi cells that are touched by this circle. And this is quite important because it creates this sort of nicer organic look to the game. And I'm going to go ahead and make this smaller. There we go. And making this a little bit more interesting, we'll create another location over here. And let's go ahead and create another area there. And this is a path that was created automatically between here. I'm going to make that a little bit wider. So I'm going to widen it with like 2. And let's see how that looks in game. This is normally almost instant. I don't know what my computer is doing right now. So here we have the first area where I'm spawning in. And here's the path. Let's see, let me just use the debugging. So here's the path going upwards. And now you might ask yourself, but we made the path to the right. And that's because in our level editor, it's actually directly using all of these 8 orientations. So each time I press play here, it's gonna use a different orientation and mirroring of the game world. And we decided to do this because it's a good way as you're like sort of iterating on the design to actually see how things will look in the game as much as possible. So what we can do here, let's go ahead and change this to create and draw. It will then also, oh my God. It will then also draw a path here, which can be good sometimes to guide the player to go between 2 locations. You just have to believe me that it works like that. There it is. So, okay, so not so fanciful so far. Let's go ahead and play some objects. I'm just creating a different area around here, but instead of the clear action, I'm going to change it to an object pool. And I'm going to make the object pool have, let's go with high diversity, no trees. And let's go with just the default. And let's cover that. This is where we're spawning. We know this is an area that clears this area. And this is an area that will place objects in open spaces. Okay, let's see how that looks. Okay, so now we have some objects here. This is using our most random setup. But as I mentioned before, it's gonna pick from all the possible objects in the game, but it's never gonna use more than 2, 3, or sometimes I think maybe 4, but I think mostly 2 and 3 objects at the same time. This is done so that this actually makes a lot of sense if you think about it. If you go out and look in nature, you usually don't have like 15 different kinds of plants living on the same 2 square meters. So it does create a high variation, but it's only going to place a few different ones. And this which objects actually belong together, these are designed in a long list of like a definition list. that our designer set up. I think there's something wrong with my computer, to be honest. I think my poor old MacBook Pro is dying. So here's a different instance. You can see again, it now has like round bushes, this fern, and these large rocks instead. And yeah. Okay, let's see if we can do something a little bit more interesting. I'm gonna move my spawn point to over here, and I'm gonna now introduce a height offset here. So again, let's just go with 500. And we have to say that this area should also apply height. And just doing a little trick here to make sure that our spawn point is actually connected to the same height. Otherwise, we might spawn next to the height on a lower level. Let's see if we can get this working. Site. Okay, so now we are on top of a hill here. It's not that easy to see, but let's zoom out. It's probably the fastest way. We raise this area. It creates a smooth height difference down to this previous starting point. And you can see that the objects have only been placed around this area because that was only where we only had objects placed there. So if we go back and say we want to have some different objects, like maybe over here, we can go and do that. Let's say we only want to have flowers and they should be fairly sparse. And we can also define that they should only be at a certain height. So we are on a height right now, so we want it to be, say, the height was 500. So we're going to define that this object pool is only going to be valid between height 200 and 600. And we also have priorities here that we can set. So this means that this object tool here will place objects at the lower level, and this will place objects at a higher level. And then when we go into the game, we should hopefully have the intended result. Okay, so you can see the flowers being placed here at the higher level. I'll just zoom out instead of walking over there. Yeah, it will, somewhere here in the middle, it will start mixing the object pools. And at the transitions, it will sometimes pick a few objects from the other one to have sort of like a smooth transition automatically between these areas, and so on. So let's see if we can make something a little bit more interesting here. I'm going to create another area, open area over here. I'll create another area. Everything is areas and nodes. Let's make a little swimming pool over here. That should be good, I think. Let's hope that works. Let's maybe add some fishes. Where are the fishes? No, this is all a custom game engine. Yeah. So let's add like 50 fishes. Sorry, I didn't mention this. This is all a custom engine. And let's see if we can get this to work. Everything is a little slow. Sorry about that. think my computer doesn't like streaming and playing games at the same time. So here we go. We now have an open area below here. Oops. There we go. We have an open area below here. It's lake. It has fishes in it. And we kind of want to go down there. So let's see if we can make that happen as a final. We're going to try to place just one object here. And it's, wait. No. It's an object that you can use to jump on. And we're going to try to place it here, but this is sort of hard to get this. If I just place this here manually, I'm not going to know if it's going to be on top of the hill or just below it. So we have sort of a flag here where it tries to snap things to just on top of cliffs or on bottom of cliffs. So I'll just activate that flag, place it here, and hopefully it will work. Let's see what happens. And there it is. This isn't a very hard puzzle right now, but it still might be hard to do it because the game is running at maybe a few frames per second. So you get to see the game in slow motion too. And there we are, swimming with the fishes. So in this way, we build up levels. And as I said before, I've only really skimmed on the surface of what the functionality is in our level editor. There's a lot of other ways to create randomness. You can, for instance, do random offsets where you say, okay, this is going to be in anywhere between minus 5,000 and plus 5,000 in either direction, which means that this will be placed anywhere along this line. You can hook objects into each other, saying this object is a parent of this object and so on. And then you can say that any of these like 3 child objects, only one of them should be placed at this location with like these random chances and so on and so forth. But I think I'm going to stop there because the level editor is really, really slow because of the streaming. Normally, the workflow here is like instantaneous. You just press play and you immediately are in the game. So these loading times are not something we usually saw through the game design process. So I'm just going to close this down, and I think we can probably go to questions actually right now. So if any, I don't know how that works. There's, oh, something pops up here. So I'm going to read the questions. So Matt asks here, how are you placing small objects so that they match adjacent cells? I can't tell where one cell starts and another begins, which is impressive. How are you doing it? It looks like clumps of flowers can cross cell borders. Yes, exactly. They can actually. We realized that it creates a more organic look if when you do this like noise objects, which are the flowers and the very tiny rocks, if they can sort of overflow the cell where they start, that creates a much more organic look. And that's basically it. And they just we start by placing one, and then we just place them like organically. Basically, think of it as how they would spread if they spread by themselves. Okay, go to the next question here. Using the elevator seems fun and satisfying in its own right. So my question is, does this game expose any world making to players? If yes, why not? No. We did not publish the elevator. We thought about it. We also thought that it probably is like a very small target group and decided not to do it, basically. Okay. Is any of the generation placing happening in real time, or everything placed once at the beginning? So in a scene, everything has been placed as you enter the room. Or rather, when you're, so I call it rooms or scene. Sometimes it's the same for me. But so when you are in an area, all the adjacent areas are generated at that point, because we don't really know how fast you move through the world. So when you are in one area and it's connected to, say, two other areas, those two areas are generated at that point. And then, but then if you don't actually enter them, we throw them away, so that we can do this sort of dynamic progression thing, that if you go somewhere else and come back and then enter that area, we want to maybe generate it differently. So the game is printed in mostly 2D. I was wondering if you thought of rendering the scene in one monitor while displaying the editor in another. Would that improve? Yeah, I mean, I think it almost would have been possible, but it wasn't really necessary, because like now when I was showing the game, it was quite slow, but it is actually super fast. So you just like press play on a button and you're almost instantly in the game. So the way we did this is that you could just move around the spawn point or place new spawn points. So if you wanted to try out a certain area, you just like move your spawn point there, and you just flip instantly between the game and the editor very, very fast. So it worked without having like a live view mode, and I guess it was easier also. So let's see if we can read. So the question here is, at the validation stage, do you express to the system what is good enough? If yes, how? Yeah, not really. We have basically we have hard rules. So or some validation rules had ranges. So it could let me think. Like we could say that the world had to have between 8 and 10 rooms in it, for instance, because sometimes in some scenarios when you generate the world, you could come up with a situation where maybe the world just generates like 4 areas because of how the areas were placed. And so for this case, we had sort of, okay, this has to be at least like 6, but not more than 8. So we had some of that, but there were always hard rules. Like if you failed the rule, we threw it away and did another one. Okay, so when creating the areas where objects are placed, can you also define rules, relationships of how they are placed? For example, if you want all rocks to have flowers around. Yes, we could do that. So we definitely had the situation where like the small rocks should come together with either small stones or with like small flowers and stuff like that. So, and these were all handcrafted, like basically like a huge long list of not JSON, but something similar to JSON, like different, how to say, like clusters defined. Which features of the player performance are being used to generate the next world, and what for? Yeah, so basically, when you go through the world, we track which puzzles that you have solved, or which scenes that you have successfully solved the puzzles in. And these are used as a lookup to define which other harder scenes or areas you sort of unlock in the game. Okay, did you have a robust conceptual design before you started working, or did you iteratively design the game? I find the PCG is sometimes tricky when you have to iterate at the macro level, which is scaling at the macro level. How do you balance that during design of that? We had like a rough idea, but we spent a lot of time iterating. Like I would say like too much time. This game took way too long to build, and it would have been better if we had had a more clear idea from the beginning. We tried to balance it by, as I mentioned in the talk, we tried to do it so that we don't have like one procedural system that generates the whole world, but we rather have like a game design that defines the game, and then we sort of plug in these like different systems that support the game design. So the game design is sort of the structure that we hook in and then, because then you can go and replace the system that does the placement of flowers, for instance, and it doesn't influence how the macro level world generation is done. Like we had different seeds for this also, so if one flower less was placed, it didn't like generate like a completely different world and stuff like that. So it's important to segment your systems in this way, I think, so that you can completely switch out one part of the engine and without like any other system in the engine breaking, basically. I hope that answers the question, and I think we are out of time. Maybe, wait, are there any more questions? No? Okay. Well, thank you for listening. It was fun.